Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 938. Range sum of a binary search tree. Given the root node of a binary search tree and the two integers low and high, return the sum of values of all nodes with a value in the inclusive range low, high. So we want to take the sum of all nodes whose value is in this range. And this low and high is also included in the range. Okay, what it signifies? Let us see this example. The first example is that we have a low as 7 and high as 15. Now, initially I can say, what are the node values that are in between this range? I can say this 10 is in between the range. Yes. Now again, I can say this 15 is in between the range. Yes. Now again, I can say this 7 is in between the range. And understand this? Other than that, I can say all are not inside my range, right? So I will take these as a sum. So it is 10 plus 7 plus 15, which is equal to what? 25 plus 7, which is 32. So 32 is our answer. Can you understand this? Fine. Now, how can we do this? Okay, to do this, we can do a simple level order, or a DFS. So these two approaches on the different binary search tree. Okay, what signifies? Let us take a DFS solution. Okay, first of all, I am at where? I am at here. I am at this 10, and initially I will go for what? Go for left and also for right. So I can do a pre-order traversal here, right? Okay, I am going to the right side 5. Okay, now again I will go to this 3 again. Yes, then again I will go to what? This null. Okay, so I can do the post-order traversal here. Okay, now when I encounter this null, I will return what? A 0, and I go here, and again it is null. So when I encounter a null, I will return 0. Now again, from this 3, I will return whether this 3 is in my range. No, it is not in my range, right? Okay, so what is my subtree's sum? It is 0 plus 0. So I will return 0 plus 0, which is equal to 0. And for this 5, again I will go to this right side. Okay, for this also it is null. These both will return what? As 0 and 0. Now the 7 will return what? Okay, myself, I am in the range, and my subtree is also what? Returning some values. So I will return both of them. So it returns what? A 0 plus 0 plus 7. So it will be 7. Okay, for this 5, what is the left subtree value? It is 0, and right subtree value is 7. Now I will just check whether this 5 is in my range. No, it is not in my range. So just send what are the subtree sum. So subtree sum is 0 plus 7, which is equal to 7. And then for this 10, again I will go to the right side. Okay, now again I will go to this 15's left side. So it is null, it returns 0, and again I will go to the 15's right side. Again it goes to the left side, it also returns null, and right side also returns null. Okay, now I will check whether this 18 is in my range. No, it is not in my range. So what I return? I will return the sum of left and right subtree. So 0 plus 0 is equal to again 0. So for this 15, I can say from my left subtree it is 0, and right subtree is also 0. And 15 is my range. Yes, it is in my range. So I want to return what? I return a 15 plus 0 plus 0 is equal to a 15. And for this 10, again I want to check whether this 10 is in my range. Yes, it is in my range. So I will return what? 10 plus 7 plus 15 is equal to what? At 32. So 32 is my output. So this is the just a pre-order or post-order traversal, right? In pre-order traversal, we're going down, we will do addition. Okay. In post-order, we are just going down, and we will return the sum of itself and sum of the 3 nodes. Subtree and right subtree and left subtree. If it is also in a range, I will send it also at a sum. Okay. So this is the normal approach, right? Okay. So what is the time complexity for this approach? I can say time complexity will be O of n, since we are traversing each and every node, and space complexity is what? O of h, because we are using what? A recursion here. So recursion will create in the stack, and this intercept will be what of space complexity? It's space complexity will be a height of this tree. Can you understand this? So this is my time and space complexity, right? Okay. Now let us understand what is the main purpose of using a binary search tree. What is the main purpose? Okay. The property of binary search tree is in left subtree. In left subtree, we have what? A smaller value than the root. Yes, and in my right subtree, I have a larger value than the root. Okay, so this is the main observation I have binary search tree. So let us take the same example here. Now listen this carefully. If I take the same example and execute for the binary search tree, first of all, I am here, right? And what is my low? Low is 7. And I is what? 15. And I want to check whether this 10 is in my range. Yes, it is in my range. So this 10 is also contributing my value, right? As my sum. Okay, now I want to go to the left as well as I want to go to the right also. Can I understand this? Because this 10 is in my range, right? Okay, now I'm checking for this 5. Okay, so while checking for this 5, I'm observing that, see this carefully, 5 is what? Is less than this range. Is less than this low, right? This 7 is less than this 7. So I can say, going to the left subtree of this 5 is not important. Can be ignored, right? So I will go to what? I will go to the right subtree. I will go to what? A right subtree, and I will return whatever the value that are returned from this right subtree, because it is what? It is not in my range. So that maybe there's a possibility of having the nodes that are in range of this in my right side, right? So I will go here. Okay, now, okay, for this 7, I'm checking whether this is in range. Yes, this 7 is in my range. So I can say this 7 is going to contribute some value, right? Yes, the 7 is also in my sum. Okay, now I am going down. It is what? And null. And also here, it is also null. So I will return what? 0. And here also 0. And the 7 return what? 7 plus 0 plus 0, which is equal to what? As 7 here. Can I understand this? Now, again, from this pi, what I return? From this pi, I return, here is 7. And I don't take my left subtree. So 7 plus 0. Because this 5 is not in my range, right? That's why we are not contributing our 5 as our answer. So 7 plus 0 is equal to what? 7. So for this 10, the left subtree returns what? As 7. Okay, now it's time to go for the right subtree. Now, whether this 15 is in my range? Yes, it is in my range. So this is going to contribute some answer. Okay, now it's time to go to what? A left side and also in the right side. Okay, if I go to the left side, it is what? A null. So I return what? As 0. Okay, if I go to the right side, it is what? 18. 18 is in my range? No, it is greater than what? It is greater than the 15. So I can say, going to the right subtree. Going to the right subtree is not necessary. I can go only to what? A left subtree. And in my left subtree also, there is a possibility. It is not like definitely, it is like the possibility of having something in my range, right? Because it is what? Lesser than 15 and greater than 7. So the left subtree should be what? Is less than the 18. So there's a possibility. So I'm going there, but here is null. So I return 0. And this 18 is contributing in my answer? No. So I return what? As 0 here. Is this 15 is contributing in my answer? Yes. So I return what? 15 plus 0 plus 0, so 15. So I can say for this 10, my left subtree returning 7 and right subtree is returning 15. And this 10 is also included in my answer, right? Because it is also in my range. So I return what? 32. So 32 is my put. Can I understand this? So by doing this binary search tree technique, we are just ignoring what? Ignoring left subtree or right subtree in some cases, right? So the time complexity is somewhat efficient than this normal search, normal binary tree approach. Okay, like a normal pre-order approach or post-order approach, right? Okay, what is the space complexity and time complexity? I can say my space complexity, time complexity will be O of H in my best and average case and O of N in my worst case. I will tell you why. And space complexity will be O of H because the height of the binary tree is the space complexity, since we are using what? We are using an internal stack. But we are using a recursive call, right? So for the recursive call, it takes what? O of H at most. And why it is O of N for the time complexity? Okay, let us analyze it. Because see here, in some cases they may ask some like a skew tree, or some is all the row node are in my range. Sometimes all the nodes are in my range. For this tree itself, I will give my low as something like my low as maybe a 0 and my high as maybe 100. So in this case, all nodes get traversed, right? So at this case, we will get what? A O of N back. So it is a worst time complexity we will get. So I can say in best and average case, I will get what? O of X. So this is my diamond space of the analysis. So let us see the code so that it's more clear. So here first we can see now binary tree code, depth tree of just root. If not root, just return 0. And the result is equal to 0. If my current value, root value is in my range, then what will I do? I will take the test by result, right? So we are doing here what? A pre-order traversal. That I told you what? A post-order traversal. After traversing, if I do, it is a post-order traversal. In my drawing explanation, I told you a post-order traversal. Here I am telling you pre-order traversal. That's it. You can use any traversal here. Okay, that's the important thing. Okay, now return result plus 3 of left left subtree, and also I'm going to for the recursion call for a right subtree. So what I've written here, if it doesn't contribute in my answer, then leave it. The result will be what? 0 only. But my left subtree can be there is a possibility to contribute my answer, and my right subtree can be having some values that contribute to my answer, right? So I will go to the left and right subtree and take the addition of them, and I will return it. So at last I will return what? A tree of root. So this is a function call. Let me submit it. Okay, now let us see the binary search tree approach. See here, in this binary search tree approach, first of all, if tree of root, if not root, just return 0. And result is equal to 0. Now comes the whole thing. See here, if root dot value is less than low, which means what? It is less than the low, which means it is lesser. So I don't want to go to the left subtree. I go to what? A right subtree, and I don't take the current root as a contribution, right? I will take only the right subtree as our contribution, because it may have some possible value which is in the range. Okay, now if it is the root node, the root value is in my range, then what will I do? I will just return what? Root dot val plus tree of root dot left and tree of root dot right, which means what? I will take the current root node as our answer, and also I will search in my left subtree, and also I search in the right subtree, and I will get some possible answers, right? Okay, now if root dot value is greater than type, what should I do? Which means in my right side, in my right subtree, there is no nodes which are in my range. So such that I can go to what? A left subtree. So that's what I am just going to the left subtree and returning it. And at last I will return what? A result. Okay, so this is not important. This result is not important because we are returning here itself, right? We are returning here itself. Okay, now return tree of root. Let me submit it. Yes, it is submitted successfully. Thank you.
Yeah, I'm a dad, mom.
Yes, a little bit.